We are going to discuss the first case in this video lecture, as well as its variation, which is case number 4. So in case 1, the object is dropped from rest, and commonly the dropper of this object would be positioned or is on top of a certain height. So the object will be traveling from point A, which is the top of the building or the top of the cliff, and point B is the ground. So the object would have to travel point A to point B, which is equal to the height of the building. So the drop happened at the very edge of the top of the building, and point B is the ground. So again, the object would be increasing in speed as it is going down. So on the right here are the two important information that you have to remember. At point A, since the object is just dropped from that height, the initial velocity is equivalent to 0. And at point B, the velocity or the speed of the object just before it hits the ground is a negative value. Now, let's take a look at the three equations that you are going to use in case number 1 of free fall problems. In number 1, the velocity is equivalent to the acceleration due to gravity multiplied to the time. So you're just going to get the product of g, which is equivalent to negative 9.8, with whatever time is given to you. So when do you use this problem? So you would use this equation rather when you are asked to get the speed of the object that is free falling after a certain time. So let's say 2 seconds or 3 seconds of fall. So if that is the case, since you already always know what is the value of g, negative 9.8, you're just going to multiply the given time. And you would, of course, get a negative value since the object is going down. But a clue for you is that as time goes by, the speed should also be increasing. So in other words, the speed at time equal 2 seconds should be lesser than the speed at time equals 3 seconds. The second equation is used to obtain height. You can use this, of course, if you are asked to find how high the building or the cliff from which the object is dropped. So the equation says here that distance is equivalent to the 1/2 of g. What is the 1/2 of 9.8? That's 4.9. Multiply to the square. Don't forget to square the time here. So this is used to get the distance traveled by that object after a certain time. Okay, so it might mean getting the distance traveled or how much distance have it traveled after 2 seconds or 5 seconds, and so on. The third and last equation is used to get the time it takes for the object to reach the ground if it was dropped from the top of the building or the top of the cliff. So this is the most complicated out of the three equations. So this is how you would use this equation. First, you would multiply the distance or the height of the building by or to -2. And then the product you would divide by 9.8. Whatever the quotient or the answer to that division, which should be positive, you would get the square root of that to get the time in seconds. Okay? So again, multiply the 2 of this, divide this by g, and then get the square root of the quotient. So here is a sample problem. A stone is dropped from the top of the cliff. So right in the first sentence, you would usually know what case you are solving. So here it says that the stone is dropped from top of the building or top of a cliff. So you know that this is case number 1. It is seen to hit the ground below after 3.55 seconds, which is the time it takes for the stone to travel from point A to point B, 3.55 seconds. So you are asked to get the height of the cliff. So if you remember the equations, or if you remember the figure first, here is the figure that we have for case number 1. Here, some important information has been added. Like for example, at point A, the time is still 0 seconds. And at point B, which is the ground, the time elapsed has been 3.55 seconds. So if you remember the equations, when we are asked to find distances or height, what we use is the second one. So you will use the second equation to solve for this problem. You can pause the video and try to arrive at an answer and check the problem set for the answer. Sample problem number 2, here you have two unknowns. The first one is how long it took King Kong to fall straight down from the top of the Empire State Building, which have a height of 380 meters. And B, his velocity just before landing. So landing here pertains to just before reaching the ground. So in letter A, you might be confused because you saw the word long, how long. So this is not asking for the distance. So you have to read this in full context. It says here how long it took King Kong to fall straight down from the top of the Empire State Building, which means that you are being asked about the time, and B is you are asked about the speed. Velocity is another term for that. So you can illustrate the problem if that's helpful to you. At point B, you see here distance is equivalent to negative 380 meters since this is downward. So that's why the negative value here. So per letter A, what you would use, actually this is wrong, what you should use is equation number 3. And for letter B, of course, you will use equation number 1. Okay? I will, you can pause this video and solve for the unknowns using equation 3 and equation 1. Okay, after case number 1, let's go straight to case number 4 because case number 4 is just a variation of case number 1. So you can see here that the illustration is still the same, but here we have a little note that at point A, which is the release point, the very edge of the top of the building, the velocity is no longer equal to 0. Since you apply force by throwing it, a word is missing here. The object is thrown downwards instead of being dropped. Since you applied force, there is also an initial speed. So at point A, the velocity is not 0, but it is a negative value. Negative because the object is going down. At point B is also a negative value, but should be larger than the initial. So here are the equations that you will use for case number 4. So if you will notice in equation number 1, which is you will use to find the speed of the object after some time has passed, it is quite similar with your equation 1 for case 1. The only thing added here is the initial velocity here, which is added to g times t. Okay, so whatever is the negative initial velocity, just add that to the product of g times t. And then for the distance traveled by the object after some time, this is still similar to equation number 2 of case 1. The only thing added here is this one. You can see it right after the equal sign. The product of initial velocity times time. Okay, so for equation 2, time appears twice. So here on the first term, multiplied to initial velocity, and on the second term, which you would have to square. Okay, so let's take a look at the sample problem. A ball is thrown downward, so right there is your clue, with an initial velocity of 3 meter per second instead of being dropped. So here, be mindful that although it is shown here as 3 meter per second, in your calculation, you have to use negative 3. So you have two unknowns here. What then would be its position after 1 second and 2 seconds? This is a very good problem because instead of being asked height, you are asked position. But you should still interpret that as distance or height. What would be its speed after 1 second and 2 seconds of fall? So you have two calculations for each letter because there are two times that are given after 1 second and after 2 seconds. So here, it would be better if your illustration shows -3 actually here. So for letter A, you're asked for position or distances. Mm. You should be using, okay, you might be confused here, so you should be using VI times T plus 1/2 GT squared. And for the final velocity, you should be using VI plus GT. Okay, pause this video and try to solve for the distance and the speed. Both of your answers should be negative.